Hello and welcome to the first of a new series of demonstrations of new features and experimental development in the EMF Compare technology at Eclipse. Today we'll have a look at the customization and enhancement of the user experience of Compare Merge using facade models. So one of the classic use cases of a facade is for a representation of domain-specific languages that are implemented as UML profiles in a more simple and true to the domain concepts fashion. So for the purposes of this demonstration, I have a tiny profile that is loosely based on a very sketchy memory from a long time ago of some of the basic concepts of J2EE. Never mind the details, suffice just that there are stereotypes such as bean extending the class concept with a bean kind attribute. There are home interface, finder interface stereotypes of the interface concept that, although it isn't explicitly indicated by the profile, are linked to the bean class that they're about by means of a usage dependency. So just a very minimal little profile for our domain-specific language concepts, and an example of its application to a minimal UML model. We have a couple of things. We have a home interface for the thing bean. So the interface is linked by this usage dependency to the thing bean. And similarly for a finder interface, in which case we use a create usage, the create being a UML standard stereotype for usage dependencies. So a very simple structure, just about the most minimal conceivable UML model for a demonstration such as this. Now where it gets interesting is when we want to do comparison and merge operations. So let's get to that. This model is maintained in a Git repository. This workspace version is the head of the master branch, which makes changes as compared to an initial commit here. We also have what looks like an experimental branch that also made some kind of changes. From the descriptions, it looks like on the master branch, we added a home interface for the other bean, the what's it, and also it appears that we did something similar on this experimental branch, in addition to adding some another finder interface for the other bean. So that's good. Let's delve into the details of what exactly did we change on the master branch first. So let's do that. So let's go in here and we'll compare with the previous version. And so here we see a domain-specific representation of the changes that were made. So looking at an overview here, we can see in terms of the concepts of our domain-specific language, we added a what's at home interface. It knows the bean for which it is the home interface, and what will become important later is that unlike in the UML representation of things, in our case the bean also has a reference to the home interface that is its home. So that's a bidirectional relationship. And that's reflected here in the structural differences. The what's it being got a relationship, or got a reference to the home interface that was added. So that's the changes on the master branch from one version to the next. Let's do the same on the experimental branch over here to see what changed. So let's compare with the previous version. So a similar sort of view we see here once again on the branch. We also added this what's at home interface, and as remarked in the comment, we also added another Finder interface for the thing bean. So the interesting thing being that a bean can have multiple finders. A bean can have at most one home interface. And it appears that what happened on the branch here when we created this new what's at home interface, we set its bean as the thing bean, not the what's it bean. So that will be something interesting to review when we try to reintegrate these changes into the master branch. So why don't we do that now? Go back into the history, and what we'll do this time is we'll compare the branch with the working tree, which is the head of the master branch. So this does a three-way comparison under the hood, as you can see here. And this raises up a conflict. So what happened is that we added, on both sides, we added this what's at home interface on the left side in the master branch. It was added with a reference to the what's it bean, which presumably is correct. And on the experimental branch, it was added with a reference to the thing bean. So that's our conflict. And also on the right-hand side, the consequence of that is that the thing home interface lost its reference to the thing bean, because this reference being a bidirectional reference, when the thing bean changed its home interface, the old home interface lost the reference. But there's also then this other change that is not conflicting, which from the branch just brings in a new Finder interface that's not related in any interesting ways to anything else. So what we can do now to resolve this situation, I mean, first we can just trivially accept this incoming change here. That's good. And to resolve this conflict, what we'll do is we'll say the master branch had it the right way around. So let's accept the change from the master branch that adds the what's at home interface as the home for the what's it bean. And then that, by the EMF Compare engine's knowledge of dependencies between opposite references and so on, automatically rejects the changes coming in from the right-hand side, the branch. So let's save that and see what the merged model looks like. So the simple consequence here is that we get the new thing by name Finder interface linked to the thing bean by this create usage. So that came in from the branch, and we rejected the changes from the branch that created a what's at home interface referencing the thing bean. So what we're left with here is the what's at home interface linked to the what's it bean. So that looks like a fairly consistent picture of a sensible merge result. Now, for didactic purposes, we should have a look at what this would look like in the UML presentation. So we'll go into the preferences here, and there's a new kind of preference for facade model providers. that are plugged into the compare engine. So in our example, there's only the one, which is providing facade eCore models for UML models profiled with a J2EE profile. So let's disable that facade model provider and run our merge scenario again. So now we'll just get the UML view of the comparison. So immediately we see two things. First, that the picture in UML terms is very much more complex than the sort of pure domain-specific view that we were looking at before. We see new elements created all over the place. We've got stereotype applications, we've got usage relationships, we've got all these new classes and interfaces and things going on. But more importantly, in the UML profile terms, we don't see any conflict. Whereas in the eCore model of the J2EE facade, there's bidirectional relationships between beans and their home interfaces. In the UML terms, all that we have is these create dependencies representing that relationship, but you can have any number of create dependencies between objects in a UML model. There is no constraint that the compare engine will understand that there must be only one usage relationship for interfaces stereotyped as home interface that are supplied by any given class stereotyped as a bean. So these are semantics of the domain language that it is hard to encode in the profile and to make the compare engine understand without the use of this facade representation. So if then we go ahead and just take all the default merges, right? Let's just accept all the non-conflicting changes. Well, that's all the changes because there are no conflicts anywhere. Okay, there we've accepted everything. So let's save and see what the resulting model looks like. So here we see, as before, we see the new Finder interface for the thing bean. Looks okay, but here we have two what's at homes now. One referencing the thing bean, the other referencing the what's at bean. As far as the UML is concerned, this is all fine, but that's not really the way that our domain-specific language is supposed to work. So the facade gave us a means to implement this kind of constraint, perform the comparison in terms of that facade with those constraints, do the merge, which then the changes affected by the merge in the facade automatically update the UML model in the background, and save that out with the merge result when we save the viewer. So there you have a brief demonstration of the first prototype of facade-based compare and merge for domain-specific languages in EMF Compare. Thank you.